Hello everyone, please write in the chat if you can hear me, if you can see me well, and also if you can see the presentation. So okay, let's wait another 5 minutes and I'll be back soon. Okay, I have seen your messages in our chat, so I think we can start our presentation. 1 second, I have a little technical problem with the presentation. I'll be back in 5 minutes, or in 3 minutes, I think. Well, hello everyone. Sorry for the technical difficulties with the presentation. Right now it's the appropriate one. My name is Daria, and I'm the technical support engineer of the MES Ethernet-switches group. As a part of my job, I help out with the requests on the service desk platform, give advice on the equipment setup, and also assist with troubleshooting with any problems and issues that might arise while the Ethernet switches are in use. Our today's presentation is dedicated to the basic configuration of the MES23 and MES24 line switches. During the webinar, you can write your questions in the chat, so either our moderators will give you an answer, or just I will give you the answer at the end of the webinar. Firstly, let's consider which switch models corresponds to each line. The digit XX means the number of the downlink ports. As you can see, for the MES23 line, we can also consists of the MES23xx, MES25xx, and also MES2324. For the MES24th line, we have the MES14th, MES37th, and also MES2410, 2420xx, and MES3400xx. The webinar will be divided into the 3 parts, so let's start with the first part regarding the basic configuration on the functionality. At this slide you can see the example of configuring hostname and setting the clock. You can see that the syntax is Cisco-like, so if you have ever configured the Cisco switch, you will not have any problems configuring MES. Also, you can see that the clock is setting from the exact configuration mode. And also I would like to add that our switches supports the work of the SNTP client, which allows you to synchronize time from the external SNTP server. Let's move to configuring users and privileges. By default, all MES switches have the same username and password set as default, and they are active until they are manually changed. For example, we will configure the username Alice with the lowest level of the privilege, and with the highest level of the privilege we are creating the user with the password God mode. In this case, to give an access to just log in as the user with the 15 privilege, we need to log in locally by the Alice username. Then we should enter the enable command, and then just write down the appropriate password that we have configured, God mode. Also, on the MES23rd line, we can configure the list of the command that will be available for the user with the privilege 1. In this case, it's show run config, for example, and configure. For the MES24th line, by default, we have our list of the command. For example, they are set, show, debug, help, logout, and for example also test for the test of the cable diagnostics. Let's move to the creating and assigning VLAN to an interface in the access mode. For the MES23rd line, as you can see, we can just write VLAN 10 with the name, and the VLAN will be created. For the MES24th line, we need to activate and give the name to the VLAN separately in the separate configuration mode. Also, you can see that the initiation of the interface is slightly different between the lines. So, for example, about the MES23rd line, first digit is the number of the unit in the stack, 0 is the number of the slot on all our equipment. For now, 0 is constant for the number of the slot, and the last digit is the number of the port. For the MES24th line, I can say that you need to just specify the number of the slot and number of the port ID. But I would like to announce that approximately by the end of 2024, the stack functionality will be supported on the MES24th line. Let's move to the work with the tagged type of traffic. In our equipment, we can use 2 modes, general and trunk. In the MES24 series, if you will write switch port mode trunk, you will allow traffic in tagged format pass through the interface in the all VLAN that are created in the VLAN database. To work with a specific VLAN, you should use the switch port mode general. It works similarly to the trunk, but also allows you to remove the outer tag from the multiple ones on the output of the port. For the MES23 series, you can also use as trunk, as general for work with the specific type of the VLAN. And also I can say that if you need to remove any specific VLAN, you can use the command remove. And for the MES23 series, if you need to pass traffic in tag format for all VLANs that are created in the VLAN database, you should use command switch port trunk allowed VLAN with option all. Let's move to the configuration of voice LAN functionality, which is essential for the dynamic allocation of the voice traffic coming from the client. On the MES switches, we can configure it from the 2 sides, from the side of the switch and from the side of the voice equipment. So, talking about the configuration from the switch, first of all, we are enabling the voice LAN OUI table and specifying the first 3 bytes of the MAC address of our end client. With the second command, we are specifying the voice VLAN ID. And with the last command, we're just enabling the work of the voice VLAN based on the complaints table of OUI table. Regarding the configuration of the interface, we just need to enable voice VLAN with command voice VLAN enable. Talking about the configuration from the voice equipment side, we need to configure LODP MET network policy functionality. On the MES23 line, in the global configuration mode, we should create the LODP MET network policy, specify number of this priority of this policy. Then we should define the VLAN. As you can see, it's the similar VLAN that we have created before. And also we should decide which type of the traffic it will be. In our case, it's stack traffic. For the configuration of the interface, we should just enable the work of the LODP MET network policy and specify which policy will work on this interface. Moving to the configuration of the MES24 series, it's a little different. But for example, in the global configuration mode, we should enable the work of the LODP and decide in seconds the transmit interval of the LODP frames. In the global configuration, in the interface configuration mode, we should create this policy with the specific VLAN ID and then enable the work of LODP MET and also such features as MET capability and network policy. Moving to this slide, we will be discussing the RSTP, which is one of the modes of xSTP family. MES23 line supports work of such modules as STP, RSTP, MESTP, RPVSTP+, and PVSTP+, with an RSTP set as default. And MES24 series supports work in STP, RSTP, MESTP, and RPVSTP, and the MESTP is the default mode. So let's consider the basic configuration that we have in operation network with an example of RSTP. So globally, the spanning tree protocol is enabled by default. So to disable it, we can use command no spanning tree in the global configuration mode. With the second command, we can just choose the mode that we want. In our case, it's RSTP. With the third command, we can switch the Ethernet switch to the root state using the spanning tree priority with the value 0. By default, this value is 32,768. And let's consider 2 scenarios when the end client is connected to the interface. In this case, we do not need to create the topology with these devices. So in the first scenario, when the client is connected to the first interface, we are disabling the spanning tree on the specific interface. Globally, it still works. And then we are turning on the feature of spanning tree BPDU filtering, which allow us to discard all incoming STP BPDUs to the interface. In the second scenario, we are enabling the feature of the port fast mode. So the interface will be immediately in the forwarding state. And also we are enabling the BPDU guard feature, which will turn the port to shutdown state when it receives any STP BPDU frame. In this slide, you can see an example how to set an IP address for an interface of LAN. Also, it's accessible for the physical interface. And as you can see, we have 2 ways to define the mask, for example, bitwise or using the slash. Let's move to our next part of the webinar, which will be dedicated to the layer 3 functionality, starting with then VRRP. The protocol is designed to provide redundancy for the equipment, which acts like the default router. In our case, it's the switch. So we are starting with creating an IP address for the virtual router who will start and who will initiate the VRRP process in the desired VLAN interface. Then we create the VRRP process and assign it to a VLAN. Next, we specify the priority of the VRRP process, and also we are enabling the preemption feature, which will allow the backup router take over the role of the master if it fails. And with the last comment, we just enabling the work of the VRRP protocol in the desired interface. For the MES24 line, additionally, we need to enable VRRP in global configuration mode, and also enable in the configuration of the interface the accept mode, which will allow the virtual router access the telnet and SSH connections, for example, and answer to the ICMP request. Let's talk about the configuration of the DHCP server. Its configuration is identical on the both devices. So in global configuration mode, first of all, we should enable the work of the IP DHCP server. Then we should create the pool and define the pool itself. As you can see, we can define it with low and high options, and also by just specifying the subnet with the mask. Then we are defining the default router address and DNS server address if it's needed. Then we are moving to the interface of a VLAN in which the clients will be connected, and setting up the IP address of the default router. As you can see, for now it's just the same as we created before, but it's not necessary. And then we are just making the interface VLAN 10 on the interfaces to which clients will be connected. Let's talk about the OSPF functionality. First of all, we are starting our configuration with setting an IP address to the 10th interface VLAN. Then we switch to the OSPF configuration mode to the process and specify the router ID. In this example, the router ID matches the IP address that we have created before, but it's also not so necessary. By default, OSPF uses the highest loopback address as a default router, but if you don't have any loopback address, the highest IP address that we have created in our configuration will be used as the default router. Next, we define the OSPF in network within the OSPF will operate, and specify the area. In our case, it's backbone area. And with the last comment, we just choose which routes will be redistributed. For the MES24 line, additionally, we need to enable work of the OSPF with the command no shutdown. Let's move to the third part of our webinar, which will be dedicated to the configuration of the client port security features, starting with the .1x, and also, as you can see, the configuration on the both lines is just similar. So first of all, we are enabling the work of .1x functionality in global configuration mode. Then we are choosing the method of the authentication, as you can see, .1x on the radio server. And finally, we are defining the address and the key for the radio server. On the interface configuration, for example, let's talk about this command. By default, all our equipment have the mode multi-host, which means that if one client will pass authentication on the external radio server, whole port will be authorized. So let's change this configuration to the multi-sessions, so each client should be authorized on the external radio server. Next, with the command port control auto, we will allow the .1x to change the state of the interface between unauthorized and authorized. And with the last command, we are just enabling the authentication retry. By default, the timer of the reauthentication is set to 1 hour. Let's talk about storm control functionality. With the first command, air disable recovery with the cause storm control, we are allowing to restore the interface if it will be shut down because of the storm control. On our two lines, we should also define the measurement mode. For example, for MES23xx, by default, we have kilobits per second, and on the MES24 line, we have packets per second. So I give you an example how to change the measurement mode. Also, all our switches supports the storm control in 3 types of the traffic. It's broadcast, multicast, and unknown unicast, but on the MES24th line, the unknown multicast, unknown unicast, is named as DLF. So let's talk about the reaction to the response to exceeding the set speed. On the MES23rd line, we can configure the sending trap and log to console. Also, we can turn port to shutdown, or we can do these things simultaneously, so we can send a log to console, SNMP trap to the server, and shut down the port. For the MES24th line, the log is sent by default, so we can configure sending the SNMP trap, turning port to shutdown state, and these things at once. Let's talk about loopback detection. It also works similar and configures similar on the both lines. So first of all, we are enabling the work of the loopback detection in the global configuration mode with the command loopback detection enable. Then we need to choose the mode of the LBD functionality. On the MES23 series, as you can see, we can determine destination MAC as source MAC address, multicast MAC address, and broadcast MAC address, and base MAC address. Base MAC address is when the destination MAC will be used of the own switches MAC address. For the MES24 series, I can say that we need to configure the multicast MAC address. By default, it's broadcast. And also in the global configuration mode, we need to determine the interval of sending of the loopback detection frames and turn on the error disable recovery with the cost loopback detection. Finally, we are enabling the work of this functionality in the interface configuration mode by the command with the option enable. Let's talk about port security functionality, especially sticky port security. In our case, this mode is named secure permanent. That means that the MAC addresses will be written in the configuration. So on the both lines, you can see this mode names the same, secure permanent. So we are choosing this mode. Then we decide how many MAC addresses should be behind the port. And then we choose the violation to read traffic that will come from the unknown source MAC address. In the case of the MES23 series, it's discarding the traffic and sending an SNMP trap to the external server. On the MES24th line, it's discarding the traffic and shutdowning the whole port. Also, with the command port security, by the last command port security, we are enabling the work of the port security in the desired interface, and on the MES24th line, we can enable it from the start. Let's talk about the DHCP snooping feature, which protects against fake DHCP servers. The configuration is almost the same. So in the global configuration mode, we are globally turning on the IP DHCP snooping functionality and in the desired plan. On the MES23 series, we are marking port as trusted by one command, and on the MES24th line, we just need to write down two commands, and then a port will be trusted and uplink. The functionality of the IP source guard, it works based on the DHCP snooping compliance table and protects from the IP addresses spoofing in the traffic that comes from the client. As you can see on the MES23rd line, we just need to enable it globally and on the interface. But on the 24th series, we just need to enable it in interface with the command IP verify source port security. And finally, let's talk about the dynamic IRP inspection. It also works based on the DHCP snooping compliance table and protects from the IP addresses and MAC addresses spoofing in the ARP packets that are coming from the client. The configuration is the same for the both lines, so we are enabling it globally and in the desired VLAN. So the main part of our webinar is finished, and now we can move on to answering your questions. I think, yes, our moderators will write me down questions if you have one. Maybe you have any questions? So, okay, thank you all for attending the webinar. I hope it was helpful for you. We will be glad to hear from you any questions that you might have. And also see you at the next webinars. Have a nice day.